Welcome dear students, we are on the CEC Gurukul lecture. We are in the series of electronic circuits and we are discussing the various components of the electronics which are used in the development of the electronic circuit. In today's topic we discuss about the energy storage devices. Basically why we require the energy storage devices, because there is a great demand of nowadays as the need for the energy storage in the sector grows. So does the range of solutions available as a demand become more specific and innovation, drawing on the state of art materials and technologies are developed. So while the need is not new, the people have been looking for the ways to store the energy that is produced at peak time for use at a later moment, to reduce the imbalance between energy demand and the energy production. Energy storage is now booming in the sector. So the energy storage devices are required for this. Just that will be used to store the energy in one form. So applications are becoming more diverse and widespread geographically with the growth of variable wind and the solar energies, decentralization of the power system and the need for resilience in the network. With the output of the wind and the solar dependent on the local weather, variability can occur on the short time scales, or the time of generation may not correspond to that of the demand. For example, if we take the case of the solar, so the maximum output is normally in the middle hours of the day. As we know that the sun at its peak on the middle of the day, but the biggest demand peak is often in the evening. So the growth of the rooftop, that will be the PV, and electric vehicles are another challenge, leading to bidirectional power flows in the grid and the need to avoid local congestion. If for example, multiple EVs are plugged in the recharging at the same time. In this case, the energy storage can support the deferral of investment in the grid reinforcement. Thus, a range of solution is needed. Energy storage system can range from fast responsive options for near real time and daily management of the networks to longer duration options for the unpredictable week to week variations and more predictable seasonal variations in supply and in the demand. So key use cases include services such as power quality management and load balancing, as well as backup power for the outage management. For this we require the energy storage system. So what is an energy storage system, and how we use that, and what type of these systems are, and how we can store the various type of energy in it. So what is an energy storage system? So energy storage is the process of capturing energy generated at one point and storing it for the later use of elevate energy demand supply mismatches. An accumulator, sometimes known as the EV batteries, is the gadget that accumulates power, radiation, chemical, gravitational, potential, electric charge, power increased, temperature, hidden heat and translation energy are all example of energy. So short-term power shortage is provided by some system, while other provide long-term energy storage. As we know that hydroelectric dams, both traditional and enhanced, presently monopolize bulk power retention. So, system energy storage refers to techniques for sorting energy on a large scale inside a power grid. There are different types of energy storage can be grouped into the 5 broad technology categories like batteries, thermal, mechanical, pumped hydro and hydrogen. These are the different type of energy storage that is used. Now, other different type of energy storage are, that is a capacitor, batteries, fossil fuel storage, flywheel energy storage, superconducting magnetic energy storage, compressed air energy storage, cryogenic energy storage, pumped storage, hydraulic electricity, Tesla power pack or a power fall, and many more. These are the various electronic devices. We will discuss one by one in detail. As we know, the capacitor we all use in the laboratories, and it is a device that stores the energy in the form of the electrical charges, and these charges will be accumulated on the plate. And we all see in the lab when we perform the experiment, and we use the capacitor in the electronic circuits, and it will store the energy as it can store charges with the number of charges on the capacitor, and it stores the charges and the charging and discharging takes place. Charging and discharging takes place in the capacitor. When the switch is connected, it starts to store the energy, but when the switch is off, it discharges the charges such that the device will be on even when the device will be off. Means charging and discharging takes place when the switch is connected on and off respectively. Here, when the charge capacitor is disconnected from the switch, then energy remains in the field, in the space between its plates. So, you see on the screen that these are the capacitors which we use, and this will pass all the alternating currents without passing the direct current. So, capacitor used to pass the alternating current without passing the direct current. Here if we see the difference between the battery and the capacitor, then the battery will convert the chemical energy into the electrical energy, and the capacitor stores the energy physically in a form very much like the statistical energy, and that will be used in the electronic circuit. And it has some characteristics like it is a best nominal capacitant, it has a best nominal capacitance, it has a high tolerance, it has a high leakage current, the temperature will affect the capacitance, polarization is the main characteristics of it. Based on the polarization, the capacitor is divided into polarized capacitor and the unpolarized capacitor, and that you can see in my previous lectures where I had defined the capacitor and the different type of capacitor and its working. The amount of energy stored depends in the capacitor charge stored on the capacitor plates. So, the number of energy stored also depends upon the voltage across the capacitor, that is defined by W is equal to 1 by 2 Q square by C, where W is the energy stored in the capacitor, Q is the amount of the charge stored in the capacitor, and C is the capacitance value. The second storage devices is the batteries, and normal days we use the batteries like in the mobile phone, like in the remote control, like in many gadgets we use the batteries. So, battery is an energy storage device that enables energy from renewable sources like solar and wind to be stored and released when the customer is in need. So, it is possible to store the energy in the form of electrochemical present, in which will convert the chemical energy into the electrical energy. It is electrochemical cell has the anode and cathode, where the positive terminal is the cathode and the negative terminal is the anode. So these are found in many devices such as phones, televisions, remote control, electric cars, and many more. Many more electronic gadgets, electronic devices have these batteries. And if we see the working of the battery as an energy storage system, then it captures the DC energies which are being produced by the renewable sources, and it stores the energy in the form of DC power for the later use. So hence the generally charging, optimization, discharging takes place in the battery. It is widely used by the many electronics and electrical circuit. On the screen you are seeing there are various type of batteries. These are the very common batteries which we use. Now next is the fossil fuel storage. That is another type of the storage. Here we see that energy is stored in the fossil fuels. So the renewable sources will store the energy, and this energy is liberated when it is used as a fossil fuel. So fossils such as the coal and the gasoline will store the energy that will be released from renewable resources like sunlight will be taken, and further when it has died it will be buried for a longer period. Later when it is converted into fuel, then it is used as a energy for many purposes. So you see that here we are having the stored energy, fossil fuel stored energy, and when we require, then we use this gasoline or we use this fossil fuel energy. Next storage device is the flywheel energy storage. What is this flywheel energy storage? The flywheel means where we use the fly. It is a device that works by accelerating the rotor to a very high speed, and it will maintain the energy in the form of rotation. That's why we are using the flywheel, and it is called the rotational energy. That will be this energy in the form of rotation, and that's why it is called the rotational energy. When there will be the energy extraction of the system, the rotational speed of the flywheel is produced as a consequence of the principle of conservation of the energy. Hence, it is used electricity to develop the acceleration, such as mechanical energy is produced. So, we can conclude that it converts and stores electrical energy into the mechanical energy. It has rotors made up of the high strength carbon fibers. This fiber is suspended by the magnetic bearing and spinning at the rate of 20,000 to 50,000 rotation per minute in the vacuum. So this the mechanical, we are converting the electrical energy into the store the mechanical energy. The mechanical that stores energy will be in the form of the moment of inertia, angular velocity, stored rotational energy. This device used as a mechanical bearing that can lose 20% to 60% of the energy in the 2 hours. So this flywheel is used. Now see on the screen that this type of NASA use the flywheel. This flywheel storage system use the electricity to accelerate and deaccelerate the flywheel. But devices that directly use the mechanical energy are being developed nowadays. So advanced FEC systems have rotors made of the high strength carbon fiber composites which are suspended by the magnetic bearing and spinning at the speed of the 20,000 to the 50,000 rotation per minute in a vacuum enclosed. Such flywheels can come up the speed in the matter of the minutes and reaching their energy capacity much more quickly than that of some form of the storage. Next storage energy is the superconducting magnetic energy storage. It is a system storage energy that is developed such that it stores the energy in the form of the magnetic field. As the name suggests, superconducting magnetic energy storage. So it stored the energy in the form of the magnetic field that is created by the flow of the direct current in the superconducting coil, and that is cooled below the superconducting critical temperature. That means the temperature, low temperature is critical temperature is required to store this energy. This energy storage includes the three parts. One is the superconducting coil, and second is the power conducting coil system, and third is the cryogenically cooled refrigerator. So to store this magnetic energy, we require the superconducting coils, power conducting systems, and the cryogenically cooled refrigerator. So here shortly, once the superconducting charge, the current will not release and the magnetic energy is stored indefinitely. So this stored energy is released back to the network by discharging the coil. So here the power condition system use the inverter or the rectifier to transform the alternating current into the different direct current or the vice versa. The transformation of alternating current into the direct current or the direct current to the alternating current. But the inverter or rectifier will use 2 to 3% of the energy, and that is 2 to 3% of the energy is lost here. You see on the screen then this type of the devices we use the storage of the magnetic energy. And here the main advantages over all the devices are the time delay during the charging and discharging is shorter, and the power is available almost instantly in these devices. Also very much output can be provided in the short period of the time. Here loss of the power is also less as compared to the other storage devices. Next is compressed air energy storage. Now energy is produced by using the compressed air. In this storage, constant volume and the constant pressures are stored in the compressed air storage energy storage system. Here if we see the working, when the air is trapped and compressed such that it produces the heat, thus by producing the energy, and it is a way where the energy is generated at one time and released on the another time, and the energy generated during this will meet lower energy demand but also can meet higher energy demand. This case is system stores the energy by using off-peak electricity by compressing the air and stored it in the reservoir. So these are the system we are going and store the compressed air. Next is the pump storage hydraulic electricity, and next type of energy storage is the pumped storage hydraulic electricity, and it is a device that uses the water reserves and as a resource, so it is called the hydroelectric storage devices. It is a configuration of the two water reservoirs at the different elevation that generate the power as the water moves from one to the another side while passing through the turbine, and it converts and stores the mechanical energy into the electrical energy. And this system requires the power as the water moves from the upper reservoir. So it is quite similar to the giant batteries which stores the energy and is released whenever it needed. This is of the two type of the storage hydro powers. Number one is a open loop storage hydropower, and second is the closed loop storage. In the open loop storage hydropower, that has a ongoing hydraulic connection of the natural water bodies. So closed loop storage hydropower are not connecting to the outside water bodies. So you see on the screen that these are the system where we use the store the energy. Now this was about different types of the energy storage devices to store the electricity. I hope that this article, different type of energy storage devices, may help you a lot. Thank you for this.